Again, Unit 2 equations, day 4, one-step equations. I started to try to teach without actually videoing. Someone said, hey, video. I was like, okay, great. So let's just make sure that we can do this. Let's say I've got 3 fingers on this hand plus these 2 over here. So I've got 3 F's plus 2 F's. How many F's do I have? 5. Okay, so I've got 5 fingers. Everybody with me? Just because I've got 3 plus 2, does that change that I still had 5?
No.
Okay. Same thing. You don't write this down. If I've got 7x plus 2 plus 4x, what are my like terms? 7x plus 4x, which then gives me 11x's plus 2. This is written differently than this, but is it the same thing?
Yes.
Yes, I haven't changed what's going on right here, right? 7x and 4x give me 11x. It's the same thing. Why do we go with that? Well, let's start off with what an equation is. Yeah. Okay. And let's go back a step. What was an expression? What did we say an expression was? This was from day 1 of these notes. So go back to probably September 17th or 16th, and I bet you have what expressions were. But it was Unit 2, day 1. Sammy.
Expression is a mathematical sentence with numbers, variables, and operations, but no equal sign.
But no equal sign. An equation is more than one expression with an equal sign. So that means I'm going to have some kind of expression on the left side of an equal sign, some kind of expression on the right-hand side, and we know expressions have variables, numbers, mathematical operations, meaning plus, minus, add, or multiply, divide, those kind of things. Everybody with me there? Okay. But I want us to understand this. Equal means balanced. Okay, we know equal means the same, but the equal sign really means that whatever's on the left-hand side is exactly the same. It stays balanced. Everybody with me? Jackson, I'm going to need your help for this. So I'm going to need you to come on up, Jackson. Which side do you want to stand on? Left? I lied. Back up. Nobody saw your face. Mrs. Armstrong, may I have you for this example? Sorry, the video's going. Don't worry, we just saw Jackson's white hoodie. It's fine. Sorry. Okay. So, would everybody agree that this ruler right now is balanced?
Yeah.
My finger is the equal sign. That's the balance point. The balance of an equation will always be where the equal sign is. So at the same time, can we each put 3 fingers on this? 1, 2, 3, down. Is it staying balanced? Okay, Mrs. Armstrong, remove all 3 of your fingers. Was it balanced anymore?
No.
No, okay. Let's not put them down so hard this time. Wait, we're not done. So let's put 3 fingers on. Oh, stay balanced. Wait. Okay, lightly. Remove 2 of your fingers. So now this side is heavy. Does everybody agree with that? What do I have to do to keep it balanced? Bianca?
You put up 1 finger. You do 2 fingers and then you make the third finger.
So what you're saying is I need to take away 2 fingers from my side? So how many fingers are on each side now? 1, right? So if Mrs. Armstrong puts 4 fingers on, so now she's got her whole hand, we're no longer balanced. What would I have to add to my side to keep it balanced?
4 fingers.
All 4 of my fingers, right? This is the same thing in equations. If I change one side of the equation. Whoa! It goes unbalanced. So to keep it balanced, we have to change both sides of that equation. Does everybody understand that? Okay. But the key with keeping it balanced are using inverse operations. Inverse operations undo a mathematical operation. So when I'm talking about inverse operations, it's going to undo something with math. Everybody with me? Okay. I'm trying to get through this because, listen, I know you know how to solve one-step equations. I just want to have my spin on it. So let's talk about addition. Nope. Addition undoes what? Subtraction. Subtraction undoes what?
Addition.
Addition. Those are our basics. That's what we're used to seeing. Well, multiplication. Multiply, undoes what? Division. And division undoes what? Multiplication. Okay? We will be using inverse operations a lot. So I'm going to have a trick question for you. Because some of you might be kind of zoning out every so often. I'm going to give you the end-all, be-all answer. When I say, what are we trying to do? You'll be able to say this answer, and I'll laugh because it will be correct. It might not be the most accurate, but it will be correct. Here's what I want you to talk over with your groups. What is the goal of an equation? So talk it over. I want to hear you talking about what's the goal of an equation. Go. Huh? No. When the lesson's done, yes. So what's the goal of an equation?
But I'm guessing it's of an equation, right?
Of an equation, yes. What's the goal of an equation? Okay, come on, let's have some. What do you think?
To find a solution.
To find a solution. That's a great thing, and no. Jackson.
To get what the variable is.
To find out what the variable is. No.
The exponent.
To get it balanced, like.
Okay.
To find the inverse operation.
Not quite. Woo, 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 woo! Say it again, Megan. To isolate the variable. The goal of any equation is to isolate the variable. We know that a variable is replacing a number. It's taking the place of a number. We know that isolate means to get by itself. The goal of every equation comes down to this. We are trying to isolate, get that variable by itself. Even in huge problems that I did in college, when it's asking you to solve, as soon as it says solve, I know I'm trying to get something by itself. Everybody with me there? Okay. Let's start off basic. And I want to see this pretty much every time. And on today's homework, you're going to want to just put down an answer. and I'm going to say, no. Okay? I need to see the inverse operations. So let's start off with something as easy gets. X plus 1 equals 8. I've got specific steps every single time. I want you to cut this equation in half. So Maddie, where am I going to cut the equation in half at?
About like right after the variable.
Not quite. Where do we think that halfway point is that keeps it balanced? Evan? Brooklyn? A 1, Isabella? The equal sign, Carly, what do you think?
After the addition sign.
After the addition sign, Brendan? The equal. Remember, an equation has to be balanced. What's showing me the balance point is this equal sign. So I want you to draw a dashed line showing your left side from your right side every single time. Every single time. Because you're going to see me doing this a lot, is covering up one side of an equation. Okay? Get used to me covering up the right side of the equation and saying, what do you see now? If I just have x plus 1, is that an equation? No. That's an expression because it does not have an equal sign. Can I combine any like terms over there? No. Is there anything to simplify on this side? No. How about on this side? 8. Can I simplify anything? Can I combine like terms? Those are all questions that I'm going to be asking you almost every single time. So we've got a left side, we've got a right side. Our goal is to isolate the variable. I want the x by itself. What do I need to do in order to have 1x? Because listen, 1x is the same as just x. Those are the same.
Maybe you subtract the 1 and...
Good, stop there. I'm going to take away 1 from this side. Think about that ruler. I am now physically changing this side, because this was x plus 1. Let's consider it a pound. If I'm on a seesaw, and I have more pounds on one side, is it balanced? So if I take away 1 pound, 1 minus 1 is 0. It doesn't cancel, it becomes 0. So what happens? My x drops down. But I'm unbalanced. I've completely changed this left side. So to keep it balanced, I've used the inverse operation on the left side. What do I do to the right? The same thing. If I took away 1 here, I have to take away 1 here. So now I'm going to say x equals 7. There's my answer. Can I always go back and check it? Sure. Check. So x is 7, so I'm going to say 7 plus 1 equals 8. Check. Because 7 plus 1 equals 8. Questions there. Inverse operation. The inverse of addition is subtraction. When I told Mrs. Armstrong to take away 2 fingers, that ruler went flying. So what did I have to do? I had to take away 2 fingers. Everybody with me still? Okay. Let's go back over here. It does get a little bit trickier. Let's say I've got 8 plus x equals -2. Our steps stay the same every single time. What should I do first? Before I start to isolate the variable, what should I do first every single time? David?
Draw the dotted line
Where?
between in the equal sign.
Why? What is that point?
The balance.
That's the balance point. So right now, this is saying this side is the same as this side. Does everybody understand that? It's got the same amounts of pounds on both sides. Everybody with me? Okay. So, I'm going to cover up this side. -2. Can I do anything to -2? No. Boom. Ooh. 8 plus x. I can't combine those. So we're done. Okay? I want you to get in that habit. What do I want to isolate? What variable am I trying to isolate, Caleb? What am I trying to get by itself?
X.
The x. What do I need to move in order to have just the x? So I want just this x on this left-hand side. So what do I need to move?
8 plus 8.
The 8. What kind of 8 is that? It's a positive 8. So how can I get rid of positive 8? Maya?
Subtract 8 from 8.
Subtract 8 from 8. What is 8 minus 8? 0. So let's do this. If I put 0 plus x, what's 0 plus x? X. It still gives me x. Is everybody seeing what's happening? How many x's do I have there? 1. That's isolating it. We have one of the variable. Equals, and that's -2, right? What do I need to do still? I've completely changed this. I took away 8 fingers. Isabella?
You can subtract 8 on the -2.
So now, -2 minus 8. If I start off at -2 and I take away another 8, I owe you $2 and then I owe you 8 more. How many dollars do I owe you? Come on, let's get some new hands. Let's get some new hands. Mason, if I owe you 2 and then I owe you 8 more, what do you think?
$10.
Very good. But what kind of 10?
-3.
Very good, sir. X equals -10. Do I need you to check it every time? Not right now. How about on a quiz? You probably should. Because now I can check and say, 8 plus a -10. Does that equal -2? Well, 8 plus a -10 is -2. -2 equals -2. Woo! Check. Questions? Okay, we good there? Well, so far, all we've undone was a positive, was addition, right? -7 plus x equals -2. I like my 7s and my 2s. First step, Maddie, what am I going to do?
Gonna separate them at the equal sign.
Good. So I've got an equation, or not an equation, I've got an expression on my left, I've got an expression on my right. B, can I simplify -2? Is there anything I can do to -2? Nope. How about -7 plus x? Can I simplify -7 plus x? Well, what do you think? No. Okay. Alyssa, we're trying to isolate what?
The set part of the x.
The x. So what do I need to move to get x by itself, isolated?
7.
What kind of 7?
The -7.
Oh, -7. What do I need to do to get rid of -7, Jackson? Add 7. Guys, this is the, right here, this is the additive inverse property. -7 plus 7 gives me 0. That's called additive inverse. When I have one number that's positive, the other number that's negative, and it gives me a 0, if it's the same number, additive inverse. So -7 plus 7 is 0. Do I need to write 0? No. But this comes down. X comes down. Swill, what do I do if I change this left side? We added 7 fingers to one side. What do I have to do to the other?
I do the same thing.
So what am I going to do? Tell me.
You gotta take -7.
What do I do here? So we took -7 and we added 7. So what are we going to do to this side?
Add 7.
Add 7. Everybody with me? If you can always go back to, hey, I'm doing something with my hands. You're watching that ruler flip, right? If you can think about it like that, you can do this. -2 plus 7 then gives me +5. Questions so far? (6x equals 30). Step, 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 step. Always, 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 always. I want to see you start exactly the same. Abby, what do I need to do first? Where at? Through the equal sign. That's my balanced point. When we have a number smack dab up against the variable, what operation is that? What operation is that? Come on, I need more. Abby? Multiplication. What is the inverse operation of multiplication, Haley?
Division.
Division. So why does this work? If I divide this by 6, what is 6 divided by 6, Maddie?
6 divided by 6 is 1.
1. If I put 1x, is that isolated? Is that x isolated? Yeah. X is the same as 1x. 1x is the same as x. But do we want to write 1x? Nah. Let's just leave it as x. 6 divided by 6 is 1. We've now isolated it. But we've also changed this. So if I was multiplying 6 times on this side, we divided to undo that operation. What do we do over here? Go ahead.
Divide 30 by 6.
Divide 30 by 6. 30 divided by 6 is 5. Could we check it? Could we go back in and say 5 times 6 is 30? Yes! You always should. Are we always going to? No, because even I am lazy. I trust my math enough to be like, no, I'm not going to check it. On a quiz, when it's a grade, probably a good idea, right? Questions on that one? Oh, Mr. H, though, I guarantee that I'm going to catch some of you on this. Negative x equals 12. First step, always. First step, Bianca, what am I going to do?
Put the dotted line to the...
Yeah, show the balance point. Is my x isolated? Swill, you're shaking your head no. Why?
Because there's a 1. There's a negative 1.
Oh, there's a... Swill, you're the man, brother. There is a negative 1. What do we want? Do we want a negative 1x? Am I talking to the wall? Do we want a negative 1x?
No.
What do we want?
X.
Just 1x. So somehow we need to get rid of negative 1x. Now listen, here's the common mistake. You see negative 1 and you say plus 1. But what is this? This is negative 1 times x. Negative 1 times x. Sorry guys, hold on. Someone's got in my throat. Ugh. So what do we have to do to get rid of multiplication? Go ahead, Sammy.
You gotta divide
By?
by 1. By negative 1.
Yeah. Because negative divided by a negative is a positive. Positive what? Positive 1x. So what do I have to do to the 12?
Divided by a negative 1.
Divide by a negative 1, right, Maddie?
Right.
Okay, let's copy this down, honey. So x then equals negative 12, because a positive divided by a negative is negative. Everybody still with me? Questions? Okay, so now we've got multiplication. Almost done. Almost done. Division's a little bit different. I showed you if I give you x over 4 equals 3. And I'm going to draw 2 of them. How many x's do I have right there? I don't have 1x. And this is not 4 either. Very good, B. I have 1/4 of an x equals 3. Okay? To get rid of dividing by 4, what would we have to do? What's the undo? What's the inverse operation of multiplication? Divide is not correct. If we've got division, what's the undo? Multiplication. This is a little bit hard to understand. I am not multiplying the 4 by 4. I'm multiplying the numerator by 4. 4x divided by 4 is what? What's 4 divided by 4? So if I multiply and put a 4 in the numerator, it's really saying 4 divided by 4, which is just 1x equals. But I still have to multiply this side by 4. Bless you. What's 3 times 4? 12. Is 12 divided by 4 3? Yes. Now, if you see x over 4, why does this really work? Well, we're using the multiplicative inverse. The multiplicative inverse says, hey, if you have a fraction and you're going to multiply, flip that sucker. So it's 1/4, flip them. What do I mean by flip them? Put a 4 over 1. 4 times 1 is? 1 times 4 is? What's 4 divided by 4? Oh. That still gives me 1x. 3 times, well, let's go 4 over 1. Now watch what happens. 3 times 4 is 12. Whole numbers have a denominator of 1. 1 times 1 is 1. What's 12 divided by 1? It's the same process, but we're going to need to know that this is the multiplicative inverse, okay? Where we have to flip that. Does anybody know what it's called when we flip it? It starts with an R. What?
Reciprocal.
Reciprocal. Folks, that's amazing. Great job. We multiplied by the reciprocal. As it gets tougher, we'll be multiplying fractions like 3/7 by its reciprocal. Not often, but a couple times. Questions so far? You have done one-step equations, I'm guessing, for at least 2 years. At least 2 years, I think. Maybe a year and a half, something like that. Okay? You're going to give 15 problems a try. You've got about 15 minutes. There is no reason that you should not finish. If you don't, it is homework.